Hello and welcome to the BS Academy. Second subject of the GATE 2021 is Production Technology. In the second subject, the fourth chart of the production technology will be related to the metal forming processes. In the fourth chart, will include that the flow stress, then the rolling process, then the tube drawing, then the forming process as well as the forging process, and at the end the non-traditional machining methods will be there. All the formulas related to these processes will be covered in this chart, so please watch the full video till the end. Let's begin with the first one, which is the flow stress. As you can see here that the stress at any point in the strain hardening region is called the flow stress. Then types of stress strain curve are there. First one is the perfectly elastic material. The diagram is shown here for that material. Then the second one is the rigid plastic material. For that, stress strain diagram is there. After that, the elastic perfect plastic. Then elastic linear strain hardening material. For the fourth one, sigma mf is equal to sigma f1 plus sigma ff by 2, where sigma fi is equal to initial stress and the ff is equal to final stress. Then after, the fifth one is the elastic non-linear strain hardening material. For that, sigma mf is equal to k into strain raised to n upon n plus 1. So sigma f is equal to k into e raised to n. So here one note is there. During the metal forming processes, if V is equal to constant is given in the examination, then by this equation you can solve the questions. The equation will be like ln Lf upon Li plus 2 into ln Df upon Di is equal to 0. That means epsilon L plus 2 into epsilon D is equal to 0. It means where epsilon L is equal to lengthwise true strain, then epsilon D is equal to dimension wise true strain, and epsilon T is equal to thickness wise true strain. So you can use these equations of EL plus ED plus EX is equal to 0. Then coming towards the rolling process, first one is the assumptions which are taken in the rolling process. The first is the rolls are straight and rigid cylinders. The second is strips are much wider as compared to the thickness. That means W is greater than the T, means thickness. Then arc of the contact is circular with a radius greater than the radius of the roll. Then material is rigid and plastic, which is perfectly plastic. Then COF is constant on both the sides of the material. Then after, from volume consistency, HIVI is equal to HFVF. It means TIVI is equal to TFVF. Then you can say that T is directly proportional to 1 upon V. Then Vf upon Vi is equal to Ti by Tf greater than 1. Then Vf greater than Vi. That's why you can say that the velocity at the end of the rolling process is greater than that of the starting of the rolling process. Then the second equation is for enlarging zone, the percentage of backward slip, which is equal to Vr minus Vi by Vr into 100 is equal to 1 minus Vi by Vr into 100, then 1 minus Hi upon Hi into 100%. So Vr greater than Vs for the backward slip. And in the third one, in the leading zone, the equation will be like Vf minus Vr upon Vr into 100%, then Vf upon Vr minus 1 into 100%, then Hn upon Hf minus 1 into 100%. Here you can say that Vs greater than Vr for the leading zone. Then one more important equation is arc length or the contact length. L is equal to under root R into delta H. Then for self entry of plate in the roller gap, you can use this equation like first one is the mu is equal to greater than or equal to tan theta. Then tan theta is equal to mu, which is equal to under root delta H upon R. And the third one is cos theta is equal to 1 minus delta h by 2r. From the first equation you can say that mu n cos theta greater than or equal to n into sin theta. Then sixth one is for maximum draft, delta h is equal to mu square into r. Then delta h is equal to hi minus hf. Then maximum draft is directly proportional to mu square and proportional to r. Now the eighth one is for maximum reduction in area, ai by af is equal to e. Then fd is equal to sigma total into af. Then af upon ai is equal to 1 upon 1 plus beta raised to 1 upon beta, where beta is equal to mu into cot alpha and alpha is equal to semi-side angle. Then sigma total is equal to sigma y plus sigma d minus sigma y into e raised to minus 2 into mu l upon rf. Then seventh is force, power and torque for the rolling process. So you can use this equation like P total is equal to 2 into P1 is equal to 2 into 2 pi nt1 upon 60. Then second is T is equal to F into L by 2, where sigma F is equal to sigma MF is equal to sigma Y. Then sigma MF is equal to 2 by under root 3 into sigma Y. So third one is F is equal to sigma MF into 1 plus mu L upon 4h into W into L. So H is equal to Hi plus Hf by 2. Then F is equal to WL into sigma MF. Then sigma MF is equal to 2 by root 3 into sigma Y. So these are the equations for the rolling process. Now the next is tube drawing process. The drawing stress in the tube drawing you can calculate by this equation of sigma Td is equal to sigma Mf into 1 plus beta upon beta into 1 minus Hf upon Hi into beta. Then tube drawing with stationary mandrel, beta is equal to mu1 plus mu2 by 10 alpha minus 10 gamma, and beta is equal to mu into cot alpha. Then second is for floating, beta is equal to mu1 minus mu2 upon 10 alpha minus 10 gamma. Then tube drawing with movable mandrel, beta is equal to mu1 upon 10 alpha, and fourth one is sigma Td is equal to sigma Mf into ln Hi upon Hf for floating mandrel. Then sigma 2 is equal to sigma y into 1 plus beta by beta into 1 minus Hf upon Hi raised to beta. Then sigma 2 by sigma y is equal to ln Hi upon Hf. Then after jigs and fixture. So the device is used to support and guide the workpiece while repeating the production. Jigs and fixtures are used. Jigs is basically used to guide and support the workpiece, and the fixture is only used for the support. Then 3-to-1 principle of the location. You can see in the diagram the plane 1, 2 and 3. For plane 1 there are 2 fixtures are made, and in the plane 1 3 fixture is there. Here note that in order to locate the workpiece in a fixture from 12 degree of freedom, 9 is fixed by this 3-to-1 principle, and the 3 translational motion will be left in the direction of the minus x, minus y and minus z. Then different methods of the location. The first one is the flat location, then cylindrical location, then conical location, then jack pin locator, then fifth is drill bush locator, then sixth is V locator, and seventh is setting lock. Mostly the setting lock location mostly used in the drilling machine. Then after extrusion process. In the case of extrusion, the metal is compressed and forced through a suitable diameter having constant cross-sectional area. In hot extrusion process, phosphate-based lubricant plus molten glass used. And here one more note is there, ratio between the initial cross-sectional area of billet and final cross-sectional area of the product, which is equal to extrusion ratio, which nearly equal to 40:1, Then the hot extrusion process still is around 400 Gem 1. Then advantages is huge reduction in cross-sectional area and limitation is same cross-sectional area throughout the line. Then for the forward extrusion process or direct extrusion process, material is extruded in the same direction of the stroke, means F extrusion is equal to sigma extrusion into AI, and large deformation can be obtained. Then second one is backward or indirect extrusion. The material is extruded in the opposite direction of the stroke and the hollow parts are made by this extrusion process, as well as the solid extrusion can be formed. Then for the backward or indirect extrusion process, F extrusion is equal to sigma extrusion into area of die. Then there is most important equation, which is of the Johnson's equation. Sigma extrusion is equal to sigma mf into A plus B into ln R, where sigma mf is equal to K into E raised to n upon n plus 1 and R is equal to extrusion ratio, and A and B are Johnson's constant. Then ideal case, sigma extrusion is equal to sigma mf into ln into AI upon AF. Then sigma extrusion is equal to sigma mf into ln into R, and for the real case, sigma extrusion is equal to K into ln R, where K is equal to constant. Then after slab analysis, sigma extrusion is equal to sigma mf into 1 plus beta by beta into 1 minus AI upon AF raised to beta. So beta is equal to mu into cot alpha, same for the wire drawing. So these are the equations which are similar for the extrusion process as well as the wire drawing process. Then after the impact extrusion is there, it is used for softer material. Examples are like aluminum and its alloy. Then collapsible tubes are formed by this process. Then hydrostatic extrusion is used for the brittle material like wire drawings, and for this extrusion process, sigma x is equal to sigma y is equal to sigma z. Then extrusion defects are, first one is the bamboo defect, which is due to the non-uniform velocity, and the second one is pipe defect, which is equal to due to improper planing. So this is all about the extrusion process. Now the forging process. Steps in forging. Now the forging process. The steps involved in the forging processes are, first one is the fullering or the swagging, which is used to reduce the workpiece at the center. Then the edging or rolling. After that, third one is bending. Then fourth is blocking. Then fifth is flattering the workpiece. Then sixth is finishing, and after that the forging process is complete. For the press forging, in this process, fusing the workpiece into the shaped dies with help of the hydraulic press, and the production rate is faster and structure quality is good for this process. Then hardness is higher, then toughness is also the higher. Then the equations for the forging processes are, first one is in the average method, F average is equal to F into I minimum plus F into F minimum by 2. Then for the slab analysis method, F actual is equal to sigma y into 1 plus 2 into mu RF upon 3 into HF into AF. Then for the work done, E is equal to F actual into HI minus HF upon 2 into WH, where W is equal to hammer weight. Then F separable is equal to sigma mf into ln R into AI upon efficiency. Then after the barreling in the forging, in which it can occur due to the hot forging process, and in this process at the ends the metal cools faster than at the center, and for controlling this, the friction control by lubricant, and the second one is the same cooling rate maintaining proportional gradient throughout the height. Then at the end, the forging defects. First one is the left fold, second one is the unifold section, third one is the scale pits, fourth one is the die shift, and fifth one is hot tear and thermal cracking. So this is all about the forging process. Now coming towards the non-traditional machining method, or you can say that the non-conventional machining method, NTM and NCM. So first one is the form of energy. There are four types of forms of the energy. First one is the electrochemical, then the chemical, then mechanical, and the thermal. So according to the form of the energy, we have divided the processes like in the electrochemical portion, ECM, ECG, ECH and ECD are there. Then for the chemical, CM, PCM. Then for mechanical, HJM, WJM, AWJM and USM. For the thermal, EDM, WDM, LBM, PAM and EBM are there. Then the full form of laser is light amplification for the stimulated emission and radiation. In the ECM, electrochemical machining, the diagram will be like here. In this process, you can say that the reverse of electroplating process. Here, supply voltage is less than 2 to 35 DC, then high magnitude I is equal to 500 to 4000 ampere. Properties are for electrolyte, BP will be higher, then corrosiveness will be lower, K will be lower, and cost will be lower, mu is equal to also less. Then for the material, electric conductivity should be higher and K should be higher, as well as the good machinability and the stiffness will be higher. So you can choose the material with the respective properties. Then after, for ECM process, equations are there. MRR is equal to I into A upon F into rho V, which is equal to I into E equivalence upon F into rho. Then 100 upon E equivalence is equal to sigma 0 to n xi vi upon AI, where R is equal to rho L upon A. Then after, second one is ECG, electrochemical grinding. In that, it is used for the shaping and sharpening the high wear rates on expensive diamond wheels. Then low voltage and high current process it is. Then no heat damage and no residual stresses. Third one is Wdm process, electro discharge machining. The diagram is there. The workpiece will be positive and tool will be negative. As a dielectric, you can use the kerosene or deionized water, and energy per spark will be equal to E is equal to 1 by 2 into C into Vd square. Then cycle time T is equal to R into C into ln Vs upon Vs minus Vd. Then power is equal to E by T, and the average power output is equal to 0.5 into C into Vd square by T. So these are the main equations for the Wdm process. Then there are advantages of Wdm, like used for the hard and brittle material, no chip mark or no burr mark on the workpiece. Then Fc is equal to 0. Then applications are to produce the small holes which is greater than of 0.30 mm to 20 mm. Then blind cavities can be made. Then burr-free surface can be made only by this Wdm process, and the narrow dies for molding slots. Then fourth one is Wdm process, means wire electric discharge machining. In this process, dielectric is deionized water, and electrode wire diameter will be 0.05 to 0.25 mm. Then thickness will be equal to 5 mm. Applications are punches, stripper plates, dies, intricate shapes and difficult openings. For all these processes, you have to remember their applications, because in the GATE examination, the applications of the every process will be asked in the form of the tabular form. So all are very important processes. Then after, ultrasonic machining. In this process, tool vibrate with the frequency of the amplitude between the 15 to 50 microns. Then machining is for the brittle materials and poor conductors. Then abrasive materials for the USM process are Al2O3, B4C, SiC and diamond. Based on the piezoelectric effect, magneto-striptive effect and electrostriptive effect. Then applications are most useful process in the fabrication of glass, silicone, skew, round and irregular holes, then making impressions on the glass and for making the logos. These applications were asked more than 2 to 3 times for the USM process. Then the sixth one is HAM, means the abrasive jet machining. The abrasives are Al2O3 and WC and SiC for the HAM process. Then applications are cutting, drilling of metal foils, then intricate holes, cleaning, polishing and deburring of the surfaces. In this process, gas compressed and mixed with the abrasive, then passed through the outlet nozzle, so the pressure is very high in this process. Then there are two important tables for the note here. You can take a screenshot because it is very helpful notes for your examination. The first one is for ECM process. It is used for the highest MRR. Then second is USM and HAM are used for the non-metals, and the third one is LBM and EBM are used for the highest penetration with low MRR and used for micro drill and sheet metal cutting. Then there is the note for shape cutting capabilities. So LBM and EBM are used for the micro drilling and metal cutting process. Then EDM and USM are used for the die cavity, shrinking, standard drilling holes, logos and blind holes. Then ECM is used for contour cutting and fine hole drilling. Then PM is used for clean and radial cuts. Then HM is used for shallow pocketing and impression on tough glass. So this is all about the fourth chart of production technology, in which the first one is the flow stress, then after rolling, then extrusion, then forging and tube drawing, as well as all the non-traditional machining methods we have included in this chart. So please do like and subscribe to the BS Academy channel, and for the upcoming video press the bell icon, which is for the welding process, in which we will include all the welding processes. Please share this video to all the GATE aspirants of the GATE 2021. Thank you so much.